right, now you knew we could not have a section in rotational kinematics without having a baseball problem with a curveball. Now, this is just like a normal rotation, our normal kinematics problem, just it's rotational now. So we're going to go through the problem and write down all the numbers we've got. So now, first thing, we know that the pitcher is going to give the ball an angular acceleration, so an alpha of 25 radians per second squared. I know the final angular velocity of the ball, so omega f, is going to be 5 radians per second. And our job is to find the angular displacement that the ball goes through while the pitcher is giving it this angular speed. Now, we only have two numbers in the problem, and that's because the third number that we would need to solve this is not written. What we have to remember is that before a baseball pitcher throws the ball, it's not actually moving, and it's certainly not spinning. So my initial angular speed is 0. Now that I've got all the information that I need, I can solve for theta. Time is the variable that we're missing here, so we're going to pick the equation that does not have time in it, which would be omega f squared minus, or equals, excuse me, omega naught squared plus 2 alpha theta. Now we're just going to rearrange that equation for theta. So I'm going to subtract my omega naught squared to the other side. So omega f squared minus omega naught squared. I was a step ahead of myself last time. And that's going to equal my 2 alpha theta. So now I can divide my 2 alpha to the other side. And I get omega f squared minus omega naught squared divided by 2 alpha equals theta. Now we can plug in our numbers and get our answer. So it's 5 radians per second squared minus 0 radians per second squared all over 2 times 25 radians per second squared. When I plug all that in, I will get theta, which, once my calculator spits out the answer, is 0.5 radians for an angular displacement, which is not very much. A pitcher actually gives a curveball quite a bit of angular speed, enough to make it drop before it gets to the plate without actually having to rotate the ball very far.